So how do you do something really, really quick in exponential functions? Super simple. Why? You're going to always start at x equals to 0. And no matter what, when you get a base to 0, what's it going to be every single time? It's going to be 1. So all three of these graphs are going to start at 1. But I want to show you the difference here in these graphs. Okay? And this is where you're going to have to use your brain a little bit. We'll do this one in green. We'll do the next one in blue. And we'll do the last one in red. Okay? Just to show you the difference in these things. Now, it's really super simple. Check it out. Check it out. 2 to the 0, of course, is going to be 1. But 2 to the 1 is going to be 2. 2 to the 2 is going to be 4. 2 to the 3 is going to be 8. Right there, okay? And you know and I know this is going to go this way. So if you go to the -1, it's going to be a half. But once after a half, it's going to start getting so small that it's really hard to see. I want you to see the difference here. I want you to see the difference. So if I just start it right here and just go up like this, I just want to show you the difference in this. And it's going to continue on in that direction. Let's do the blue. 4 to the 0. Yes, of course, it's going to be right at 1. But 4 to the 1 is now 4. Look what's happening. 4 to the 2, 4 to the power 2 is 16. This is off the charts. It's way up here somewhere. Okay, but now let's go in reverse. 4 to the -1 is a quarter. So it's going to be actually quite small. It's going to be smaller than what this guy was. Right, because this guy would have been 2 to the -1 would have been a half, whereas this is 4 to the -1, which is a quarter, which is much smaller. See? So this guy's going to come in this way here, cut through the 1, and then just start skyrocketing up like that. Watch what happens now when we do this particular question. Same kind of idea. 5 to the 1, 5 to the 1 is 5. 5 to the 2 is 25. It's going to be even taller than this guy. So how about going backwards? 5 to the -1 is going to be a fifth. So it's actually going to be smaller than this blue line here. So it's still going to go through 0. It's going to come up through here, and it's going to take off. Look at the differences in these graphs. On this side of the axis, they start just screaming up here. And, of course, there's our normal line here with the 2. But it's just screaming away and going higher and higher and higher and faster, right? So that 5 here in your base, boy, does that make a difference in the steepness of the graph. But on the other side, look how it's also meaning that you're getting, because this is a big number and because you're flipping it, you're getting closer and closer and closer to that x-axis faster. So maybe steeper on this side, but it's definitely closer to the axis here. Domain. For every one of these things, notice they're always the same. X is an element of R. Your exponent could be any number you want it to be. Your range, guess what? Because of the horizontal asymptote, the range is always greater than 0. X-intercept does not exist. Y-intercept, always going to be 1. So your horizontal asymptote, you can actually write down, of course, as y equals to 0. If you're going to give me a formula for the horizontal asymptote, that would be it. And your horizontal asymptote, of course, is the x-axis, which goes through y equals to 0. Got it? All right. Using this kind of stuff, we're going to go forward into the next podcast, and I'm going to show you how we're going to use this.